All right, so we're working on Chapter 11 today, which is all about simulations. So we're going to go through the steps for making a simulation. Now, these are not the same steps that are listed in your book. However, I like these better, so this is the one exception where I'm not going to do something by the book. So here are the steps. Now, the first one's pretty obvious. You just need to read the question, but make sure you really understand what the question is asking you to do. In step number 2, we're going to think about what's an event. And I want to think of this as like the simplest thing that you're being asked to do. Okay, it's probably not the big picture or the big question, the smallest thing. And what are the possible outcomes? All right, what could happen? If we take that simplest event, what could happen? And I'll show you an example of this. In step 3, we're going to make sure we know the probability of each outcome. That way we know how many of each thing we need for each outcome. So thinking of like the beads, right? We worked on in class. You'd have beads and maybe we did white and black, but how many do we need so that the number represents a probability? And then we're going to think about what tool we will use. Okay, we could do an actual hands-on tool like beads in a bag. We could use our calculator to generate some random numbers. Or today what I'm going to show you is a random digit table or a random number table. So we'll check that out. And make sure we know that what outcome on the tool represents our outcomes. For example, black bead equals what? You know, boy, girl, something like that. And then step 5, what are you going to do? Make sure you explain in depth how many times we're going to repeat. What are you going to count? Like when we're all done, what is it that we're keeping track of? And then in step 7, this is actually do. Do your simulation total you've got. It's not enough to set it up. You actually have to carry it out. So we're going to go ahead and go through an example using these 7 steps. So here's my story problem. Suppose Mrs. Curtis was to randomly select 3 students from all of the AP Stats classes to speak to the sophomore class about how awesome it is to take AP Stats. Okay, so I'm choosing 3 students. We're going to go spread the word about how awesome Stats is. You know, get those little sophomores excited so they can take it their junior or senior year. So the question is, how likely is it that we're going to get 3 boys? Okay, but if I choose 3 students at random, that they're all boys. So we're going to go ahead and use last year's numbers. Last year, there were 56 students in AP Stats at the time that I was teaching simulations. 32 were girls and 24 were boys. Okay, so those are the important numbers we're going to need. And we're going to simulate me selecting 3 students to figure out how likely is it that we get all 3 boys. So I've gone ahead and copied the steps here that we're going to go through so we can talk about each one. Step number 1, read the question. We did that. Think we understand the situation. I'm choosing 3 students. Here's the number breakdown. There were 56 total, and I'm trying to figure out if I'm going to choose all 3 boys. By the way, just looking at the numbers, there are more girls than boys, so it seems unlikely that I'd get all 3 boys. But again, we're going to simulate to figure that out. Okay, number 2, what is an event? So I want to go with the simplest thing that's happening here. Now, most of the time students say, oh, Ms. Curtis, you're choosing 3 students. Well, that's not very simple to choose 3 students. I want to break it down even further. Before I can get 3 students, I need to pick them one at a time. So this is not the event, is choosing 3 students. The event is choosing 1 student. Okay, see what I mean by keep it simple. Okay, break it down to the smallest chunk. And when I choose a student, what are the possible outcomes? Well, in this situation where we're talking about girls and boys, my 2 possible outcomes are I could choose a girl or I could choose a boy. Okay, that's what I'm talking about by outcome. All right, in step 3, what is the probability of each outcome? Or how many of each thing, item, are we going to need? If it was beads in a bag, how many would I need? Well, there are 32 girls out of the 56 students total. So I'm going to need 32 somethings to represent a girl. And the boys, there were 24 out of 56. So I'm going to need 24 somethings to represent boys. So if I was doing beads in a bag, this might be, girls might be black beads. I'd need 32 black beads. And boys might be white beads. I'd need 24 white beads. Okay. All right, on to step 4. What tool will you use? Well, I told you that today we're going to use a random number table. And what outcome on the tool will represent your outcome? So since I don't have beads, I can't write white equals and black equals. I'm going to use numbers. Well, notice I do have 32 girls, so it would not make sense for me to use like the number 1 and 2 and 3 to represent a girl, because I got to go all the way up to 32. So I'm going to let the numbers 0, 1 through 32 represent my girls. Now notice I do put a 0 in front of the 1. If I just put the number 1 is a girl, and then the number 10 is a girl, if I see a 1, how do I know if it's a 1 or a 1, 0 to make a 10? So we want to keep them 2 digits. 2 digits. Everything is going to be 2 digits, just to help us keep it all straight. All right, so then my boys, I'll go from 33 up to, well, it said there were 56 students, so I'll go 33 all the way up to 56. That'll be my boys. Now, because we are going to look at 2-digit numbers, on a random number table, it's not like the calculator. I can't just say, oh, I only want numbers 1 through 56. On a random number table, I'm going to get everything. So I am going to get the numbers 57 all the way through 99, and I'm going to get the number 0. Again, to make it 2 digits, I'm going to put 2 zeros. But I don't have any more students. So I'm just going to write down that I'm going to ignore these numbers. That's okay. I'm just going to skip them if I happen to see them. Not a problem. All right, in step 5, what am I going to do? Well, I'm going to look at 2-digit numbers until I have 3 students. Because remember, the point was that I was going to select 3 students. And what am I going to count? Well, once I have 3 students, I will count how many boys I got. Okay, that's what I'm really looking for. How many are boys out of the 3? And I would repeat this. Now, ideally, when we do simulations, we would do a lot of trials. But for the sake of not trying to bore you to death on this video, I'm just going to repeat this 10 times. That still might be a lot. All right, repeat. So we're going to actually do this because I want to show you kind of how it would go with a random number table. And then we'll take a look at our results. So this random digit table came out of your textbook. You can actually Google search random digit table, find them online. Every random digit table is different. But I know it might bother you, like Ms. Curtis, we're always using the same one in our textbook. So pick a unique place to start. You don't always have to start right up here with row number 1 in the middle. On the left. You can start, I don't know, we'll start on row number 7 just because it sounds fun. And if you wanted, you don't have to go straight across. You could go down. So make it work for you. Random numbers. There's not a set requirement here. Okay, so I'm looking at 2-digit numbers. So the first 2-digit number I see is 73. That was one of our ignore numbers. So I'll kind of put a little slash through it. It doesn't count. Then I see an 18. Remember, that was a girl. Now there's a 4 and a 9, so I'm going to go ahead and cross that big gap there and just make that a 49. A 49 was a boy, right? I've now chosen 2 students, so I need 1 more. Here's a 59. That one didn't count. Remember, I'm using this system here. 1 through 32 is a girl. 33 through 56 is a boy. And remember, those numbers 57 through 99, and let's not forget 0, don't count. We just skip them. All right, so my next number is 07. Again, that was a girl. So I'll just draw a big line there to represent that I've finished a trial. And in this trial, how many boys did I get? I had 1 boy. Okay, so I'll just put like a little big 1 there to help me remember. When the trial was finished, I had 1 boy. So that's just one simulation. That represented Ms. Curtis picked Notice 1, 2, 3 students. 1 out of the 3 was a boy. So I'm going to do it again because, right, we simulate lots of times. 5, 0, 5, that's a girl. 17, it's a girl again. So I go straight across, I get a 95. We ignore that. And then 10, that's a girl again. Okay, big line to represent I finished. So, wow, at that time I had 0 boys in my crowd. Very interesting. All right, so I'll do this again. 0, 2, that was a girl. 83, we ignore. 37, hey, we got a boy there. 37. And then 45, that was also a boy. Now I picked 1, 2, 3 students. 2 of them were boys, so my simulation is finished. And I would go to the next one. Hopefully you're getting the idea here that we just keep going. 22 is a girl. 97 we ignore. 07 is a girl. 76 ignore. 90, I'm going to skip a line just because I write so big, so I'm going to call that a 90. 90 we would ignore. 39 was a boy, so that takes me to 3 students. 1 of them was a boy, and that concludes, again, that chunk of my simulation, or a trial. Now, I told you I was going to do 10, but that's so many. So I would keep going, okay? I would do 10, 15, maybe 20, keep going. And when it's all said and done, I might look at my results. So let's just pretend that I did some more trials and I got, 1 boy, 2 boys, 0 boys, 1 boy, 1 boy, and maybe 0 boys. Now looking at the number of boys I got out of 3, is it likely that I'm going to get 3 boys? Remember, that was the initial question. How likely is it we're going to get 3 boys? Well, it didn't happen at all in our simulation, so it would be very unlikely, okay, very unlikely. And we'll talk a little bit more about kind of trying to put a number, very unlikely, important prefix there. Again, we'll talk about how to put kind of a number behind that to give us a little more concrete value for how likely or unlikely it is. All right, the last thing I want to point out is a very unique circumstance, something that can happen when we're running these simulations. So just as a quick reminder, 0, 1 through 32 was a girl, 33 through 56 was a boy, and we were taking the numbers 57 through 99 and 00, 0 and ignoring those ones. So I just want to point out something that can happen in simulations. Really important for you to see this. All right, so I'm going to go ahead and pretend that this is my random number table. It's not. I made these up, but we'll just pretend. So I'm doing my simulation. 0, 2, hey, that's a girl. 25, that's another girl. Then I have 97. We ignore 97. Right, it's down here. And then look, 25, that's a girl. And then I would call it done. I had 0 boys in that trial. But there's a problem. Look, I got the number 25 right here and the number 25 right here. In this situation, the number 25 represents a person. Now, we'll say the number 25, I don't know, maybe that's like Bobette, I don't know, like Abigail. Okay, it's a person, okay? So, number 25. If Miss Curtis was really choosing out people, if I picked out, here's Geraldine, and then I pick out Abigail, and then I pick out, I'm not going to pick out Abigail again. Abigail can't go twice. So in this situation, I actually would ignore Abigail again, okay? I would ignore the repeat, and I would actually move on, okay? And then the next one would be 42. That's actually a boy, and so my result would be I got 1 boy out of 3. So back in my instruction page where I was breaking it down, I would actually write that I would ignore repeats. Okay? Anytime that your numbers are representing actual people or maybe real tangible items, we have to ignore repeats. Okay? We don't pick the same person to go twice. So that's something we're going to have to think really critically about as we're doing simulations, whether or not this is necessary. If it's not necessary and you put it in on the AP test, you can actually lose points. So we want to be really careful with this idea. All right, and that concludes our thoughts on